back, and we are going to look at basically our first question on our practice exam for exam 1 in ENGR 110. So, Boeing has received a shipment of a new titanium alloy that is to be utilized in the next generation of commercial airplanes. New titanium alloy has higher yield strength than the current material utilized. Manufacturer claims that the population mean, so mu is equal to 155 KSI. Population standard deviation is equal to 7.65, and the manufacturer sends you a box of 1,000 samples, so it is equal to 1,000. So, how many samples should exhibit a yield strength between 132 and 178, 140, 170, 147, 163, 132, 178? So, lots of kind of different values here. So, I also said that the manufacturer was kind enough to provide you with the actual number of samples. So, we found 993 between here, 960, etc., etc. So, let's go ahead and set this up. We're kind of, because the question is asking us how many are expected, and then does this sample come from a normally distributed population described by the manufacturer at 95% confidence interval. So we are going to be dealing with a chi-square test. So for a chi-square test, we need what's our observed, what's our expected. So expected, we need our number of outcomes. So for a chi-square test, we always know it's not, so same or normally distributed here. So normal. Our second step is the null hypothesis, not normal. We are specified here that we're working on a 95% confidence interval, so 95%, where alpha is equal to 0.5. We know that we need to calculate our chi-square experimental. We'll do that as it comes. And then lastly, we're going to do our critical value, chi-squared alpha nu. So we know that's going to be chi-squared 0.05. And our nu is equal to k minus 1 minus r. Because we're asking for a normal distribution here, r is equal to 2, because we're specifically asking, is this normally distributed? So now we need to figure out our number of outcomes. Well, we're given all these different ranges, right? So, for example, 132 to 178, and we observed between 132 and 178, 993. What about between 140 and 170? So between 140 and 170, we found 700. What about between 147 and 163? Well, we observed, let's see, 147, excuse me, 700 between, or actually, so, excuse me here, I had a little mistake that would have been a big mistake. So 960, so 993 between this, 960 between 140 and 170, 700 between 147 and 143, and then basically less 132, so 3 less than 132, and then finally greater than 178, we also found 4. So I have how many number of outcomes or variables? 1, 2, 3, 4, 5. So my k is equal to 5. 5 minus 1 minus 2 is going to be equal to 2. So let's go ahead and find that chi-squared value here. So let's go ahead and so many notebooks available. So again, we're only using the alpha because we can never have a two-tailed test for chi-squared. So 0.5 to 5.991. 5.991. So that's equal to 5.991. So now we need to kind of answer question A and B simultaneously by getting these expected values. So I'm going to start up and get my notebook. I'm going to delete this. I'm going to clear my kernel. Clear the kernel. I'm going to now reevaluate all my functions that I think I need for this exam. I'm going to kind of separate. This is going to be my answer to 1. And now I'm going to go ahead and list out my observed values. So my observed were equal to 993, 960, 700, 3, and 4. So now I need to figure out my expected values. So to do this, I also need to use my z function. So I could use the z table, or I could kind of solve this. Again, we're going to calculate some z values with the z function right here. And we know that, so let's calculate my first value. Let's do my z of, actually I'm going to zoom in here, excuse me for a second. I'm going to zoom out just a tiny bit. So I'm going to do my z function of, or my z of 132. So my z of 132 is, so z function, my x value is 132. What is my mu in this problem? My mu is equal to, let's go ahead and scroll up here. My mu is equal to 155. So again, you could always kind of draw in order to kind of make sure that you're on the same kind of side, or you can kind of do the trick here. So mu right here, 155. What about my sigma? 7.65. So 7.65, and that's my z value of 132. So excellent. Let me make sure that it's 7.65. Yeah, exactly. So let's do z of 178. Z of 178 is going to be 178. There. So it's symmetric, actually. So this is a nice problem. But I can now go and do if I want to figure out what's the expected 1, I'm going to do an integrate of my PDF function, which is defined over here. And again, I'm trying to look for the values that are in between these two z values. So I'm going to go PDF integrate from z132 to z178. I'm going to get that value, and I'm going to multiply. Again, this is the percentage, right? So I need to multiply by my n. So my n, is just going to be 1,000. So times 1,000. So that's my expected 1. So I could repeat this procedure pretty similarly for the next couple of problems. So let's go ahead and let's kind of scroll down a little bit. This guy's not reacting. Here we go. So let's go ahead, not this one. Oops, not this one either. Here we go. Let's move these guys. So let's go ahead and repeat this problem for the next two. So I don't want 132, now I want 140. So 140, 140, 170, 170. So this will be E2. So click, click, then again, Z140, Z170, 0, and there you go. We can do the same thing for this other one. Again, very, very similar. Again, not super exciting, but again, you're getting points on an exam, so this is a nice one to do. You definitely want this type of problem. 147, 163. Hopefully I wrote those values right, but if not, the solution should still be the same. Actually, or at least it should be correct. So right here, 147. Let's do this. 147, z of 163, and pretty close to those values. So now here comes the cool one. So I want to do, actually I don't have yet, I'm going to calculate Z132. Z132, I'm going to copy it right here. So I've got I'm going to copy this line. So now I need to figure out how many samples are less than 132. So I'm going to calculate my Z of 132, and I can see a pretty large value for that Z132 value. So I'm going to figure out less than this. So I'm going to go and integrate my E4 is going to be from -infinity to my Z132, because that's all the samples less than that. And I get this value. What about, I'm going to do the same thing for this other value as well. What about greater than, let me make sure that's actually 170, 178. Ooh, see, bad handwriting. So there definitely could be a little bit of issues, not issues there, but some math mistakes. So Z of about 178. So Z of 178. Let's just make sure again that I get those values. So that's this. So I want greater than. So now I'm going to go from Z of 178 to infinity. And I'm going to make sure to make this E5. And voila. So those are my values. So now I am just going to take my old observed minus expected squared over expected. So I'm going to say that expected exp is equal to E1, E2, E3, E4, E5. So you can look at my expected values, you can look at my observed values, and again, look pretty similar. Let's calculate them out. 7.7315, so that's our chi-squared, so 7.7 approximately equals 7.7. So let's go ahead and look at our hypothesis test. So we're doing a right-tailed test, so let's go over here. So my right-tailed test says this was something like 5.911, and then our actual value was 7.7, so we are reject. So that answer is, oops, completely Alt-5, reject. So that's it. That's your solution for problem 1. So next time we are going to get into problem 2, and yeah, let me know if you have any more questions. Thanks. Bye. And again, you can use this idea, fill in these values, right? But again, if you approach the problem this way, you're going to accumulate a lot of kind of partial credit. So I'll see you in the next video. Thanks. Bye.